All right, guys, let's knock out this practice test. See how we're doing. Number one, for that function right here, find the max number of real zeros, max number of x-intercepts, and how many turning points, okay? How many zeros does it have is the same. Maximum number of real zeros is the same as the degree, which is 8 in this case. Part B, x-intercepts, same as the zeros, because x-intercepts are zeros. Part C, how many turning points? Remember, the maximum number of turning points is 1 less than the degree, which is just 7. So that's all you got to do in number one. Number two, you got to factor number 2 before you can graph it. So if you factor number 2, you can take out an x cubed. Let me come down here. You can take out an x cubed. That leaves x squared minus 4, which you can factor that some more. X squared minus 4 is x plus 2, x minus 2. So you can put your zeros at positive 2, negative 2, and 0. There's no even exponents there, so nothing bounces. It was odd to begin with and positive, which means the left side's going down, the right side's going up, so it's going to go through all those 3 points, and it's going to look just like that. All right, I'm going to erase that one so I can put up number 3 since I only have one graph here. My graph didn't translate very well like yours did. Okay, this one you can see the zeros. I have a 0. Let's see. My zeros are going to be 0, 2, negative 1, and positive 1. Now, this one right here, that negative 1 has multiplicity 2. And what that tells me, if it's even, it's going to bounce off the negative 1. So I'm going to put those points on my graph here. Put a point at 0, put a point at 2. Oh, these are really close together. I need to make those a little smaller. 0, or maybe I can make this bigger. There we go. 0, 2, negative 1, which is over here, and also, no, I can't see it, positive 1, which is right there. They're all right next to each other. And it's going to bounce off of the negative 1 and also the degree. Count the x's. I'm seeing 1, 2, 3, 4. There are 5, which means it's odd. It's negative in the front, which means it's going to go up to the left and down to the right. Kind of what those ends do. So up to the left is coming up here. Remember, it's bouncing off the negative 1. So it's going to hit that negative 1, bounce up, go back down, back up, back down. There you go. Something like that right there. That was crazy. All right, number 4, use the intermediate value theorem to find out whether there's a 0 between 4 and 5 for this function. Okay, so we're going to take the calculator, go to y equals, punch this thing in, x to the third minus 5x squared plus 4, sorry about that. Go to table, second table, and I'm looking for 4 and 5. I'm going to scroll to find 4 and 5 on my table. The number 4 has a negative 12 beside it. The 5 has a 4, which means the signs change, which means there's a 0 between negative 12 and 4 because it went from negative to positive. So I'm just going to put yes. All right, number 5. It says divide using long division. You have to show me one long division here. So put x minus 3 on the outside. Inside, I'm going 2x to the 4th minus 3x squared plus x minus 1. And I'm looking at the first numbers. What does x need to become 2x to the 4th? It needs 2x cubed. Multiply that times everything in the front. Gives me 2x to the 4th minus 3x cubed. Remember my rule here. Draw the line, change the signs. That's gone. By the way, I can add those two, so I'm going to bring down the 3x cubed minus 3x squared. I should have skipped some space there for that. Bring down the x. What does the x need to become 3x cubed? It needs 3x squared. That's going on the top. Multiply by everything in the front. That gives me 3x cubed. Minus 9x squared. Draw the line, change the signs. That's gone. That's 6x squared plus x. Bring down the 1. What does the x need to become a 6x squared? It needs a 6 and an x. So that's going to be a 6x squared minus 18x. Draw the line, change the signs. That's going to be 19x minus 1. This is a long one. That's why it's called long division. X goes into 19x 19 times, putting a 19 in. Multiply everything in the front. 19x minus 57, draw the line, change the signs. That's going to be 56. The remainder is 56. So my final answer is 2x cubed plus 3x squared plus 6x plus 19, and then that crazy 56. Now I'm going to tell you something. One of your tests tomorrow isn't quite this long, but if you can do that one right there, you got your test covered. Okay, so that's number 5. Also, because you could have done synthetic on that one, you could also check it using synthetic if you have time to do that tomorrow. Number 6, just divide using synthetic division. It's going to be much quicker, much easier. Draw your box, put the numbers. Don't forget your 0. I have no x cubed. I have no x1. If you don't put those zeros, you're going to mess it up. All right, once you get that, remember positive 2 goes in the box. It's the opposite of what that is or what makes that 0. Start off, bring the 2 down, Every time you bring a number down, multiply by what's in the box. 2 times 2 is 4. Add, multiply by what's in the box. Add, multiply by what's in the box. Add, multiply by what's in the box. Boom. Remember the last number right there is your remainder. And we're going to start our quotient, our answer down here, 1 degree less than we started. We started with 2x to the fourth. We're going to start here with 2x cubed plus 4x squared plus 11x plus 22. And then the 43 goes over the x minus 2. There's your quotient and remainder. Number 7, use synthetic substitution. So you got to show me this to find -1. So I'm going to put -1 in the box, and I'm going to do the same thing again. I'm going to put 4 in the box. So put your coefficients here. Well, I don't have any. Yeah, I do. I have a 0 for the x squared. And we're going to start working out. Bring the first number down. Multiply by what's in the box. Add, multiply, add, multiply, add, multiply. Whatever your remainder is, the synthetic substitution is also called the remainder theorem. Whatever your remainder is, that's the answer. So it's just 10. I'm going to do the same thing for 4. So two parts to this problem, but doing the same thing. Bring the number down, multiply, add, multiply, add, multiply, add, multiply, add. This time I got 80. F of 4 is 80. Now that's the same thing I would have gotten had I plugged 4 into all the x's in there. Just a better way to do it. Number 8, determine if those are zeros. So the way you can tell if they're zeros is the same way we just did. A lot of synthetic on this test. Put -3 in the box. See if you get a 0 for remainder. If you get a 0 for the remainder, it was 0. If you don't, it wasn't. So bring it down. Multiply, add. How many times have I said this today? Multiply, add. Look at this. Look at this. I got a 0. So -3 is a 0. I'm going to just put yes. 3 is. -3 is. Sorry. Let's try 2. 2 could also be. Just because you got 1 doesn't mean this one is not going to be. It can definitely also be. 2 times 3 is 6. That's 11. That's 22. That's 16. There's no way. So that's going to be a no. Number 9. Factor that, then find the zeros. Okay. Didn't give you many hints here. I'm going to make, the factors have got to be the factors of 24. So let's do this. Let's take your calculator and let's punch that in. Let's go to y equals, let's punch in x cubed plus 5x squared minus 2x minus 24. And let's graph it. And let's just see if it crosses. It looks like it's crossing at, I don't know, +2. So let's put +2 in here. With the 1, the 5, the -2. Remember, I will know this works if I get a 0. So 1, 2, 7, 14, 12, 20. You look at that. Now, what that leaves me with is important. That leaves me this right here, which is x squared plus 7x plus 12, which does factor, by the way. What factors of 12 give you 7? X plus 4 and x plus 3. Now, one thing you can't forget. Don't forget that factor we started with. We put a 2 there. And because we put a 2 there, it came from x minus 2. So those are the factors right there. Number 10, find the zeros. This is review. Zeros of multiplicity. So -3 has multiplicity 3. That's the first factor. 2 has multiplicity 1. You have to write multiplicity 1. -4 has multiplicity 2. That's all you got to do for 10. Number 11, use the graphing calculator to find the zeros. I'm going to punch it in real quick and just put the answers down here for you. And there they are. Remember, that's where we go left bound, right bound. I start on the far left, go left bound, right bound, surround those x-intercepts and find out there were 3 of them. Remember, zeros. When you see zeros, it means x-intercepts. Find those x-intercepts. Second calc, number 2. All right. Number 12, solve that one. 2 bars, 2 answers. 2 bars, 2 answers. So you got to isolate it first. Let's move the 5 over first. Still have the absolute value there. That's going to be 3. And then you can take it away. X minus 2 is 3, and x minus 2 is -3. Just move the 2 over. That's 5. Move the 2 over on this one, and I get -1. There's your 2 answers. Number 7, solve this one. 2 bars, 2 answers. If it's less than, don't forget less than. You can set it up like this. It's an and problem, so you can set it up just like that. Add 7 to all 3 sides. I get, over here I get 19, over here I get -5. I'd rather you write your answer in interval notation, like that right there. Number 14, almost done. Number 14, start off by factoring the bottom right here, x plus 3, x minus 3, and then tell what x cannot be, like x cannot equal either one of the 3's, and multiply by the LCD, and the LCD is x plus 3, x minus 3. I'm going to do every term times x plus 3, x minus 3, every single term by x plus 3, x minus 3. And watch what cancels. What happens on the first one is the x minus 3 is canceled. That leaves a 5 and an x plus 3. So multiply those. 5 times x, 5 times 3. On this one, the x plus 3 is canceled. So I'm going to do a negative 3 times that, which is negative 3x plus 9. Over on the right-hand side, everything cancels. That just leaves a negative 2. And then it becomes pretty easy. 5x minus 3x is 2x. 15 plus 9 is 24. That's negative 2 over there. Move the 24 to the other side. Divide by 2. Negative 13. Make sure it's okay. And it's okay because it's not one of those. There's your answer. Number 15. Simplify. This is square. Multiply double square with an I. Okay, square the 2. 4. Multiply together double. 2 times negative 5 is negative 10. If you double negative 10, you get negative 20. Square the 5i. Anytime you square something, it becomes positive automatically. And don't forget to square the I. Now, 25i squared is really negative 25. And you're going to add that to the 4 in the front. 4 and negative 25 is negative 21. And I've got negative 20i. There you have it. Last one, 16, quadratic formula. Here it is in case you need it. X equals negative b, or in this case y, plus or minus square root b squared minus 4ac all over 2a. You got to know that. So y equals negative b, which is positive 5, plus or minus square root b squared 25 minus 4ac all over 2. And I'm just plugging those numbers in. So work out what's inside there. That's going to be 25. If I see 2 negatives, which makes it positive, that's going to end up being 49 inside. And I know it's square root of 49. Now, you may be done right there. If it's a square root you don't know, you can stop right there. But because we do know the square root of 49 is 7, I got to take it out and keep on working. 5 plus 7 is 12. 12 divided by 4 is 3. 5 minus 7 is negative 2/4, which is negative 1/2. And there you have it. Hope that helps. Wear this video out. Use as much as you need to. Come see me tomorrow if you need to for the test. Hope you do great. I'm sure you will. See you then.